This video will cover arithmetic series. This is going to be a very basic introduction to the idea of arithmetic series. We'll do a couple of examples though. An arithmetic series is the sum of the terms of an arithmetic sequence. Now, the symbol for this is going to be S sub n, S for series, and then n will tell you the number of terms being added. Now, we're going to use that symbol over and over again in this chapter because that is not the symbol specifically for arithmetic sequence, but rather the symbol for what is called a partial sum. A partial sum is the sum of a specific number of terms in a sequence. Okay, so an arithmetic series is one type of partial sum. Okay, again, that symbol S sub n really stands for partial sum, not arithmetic series. We're going to use the exact same symbol when we get to geometric, and we're talking about geometric series. That is the sum of a specific number of terms in a sequence. So here's an example. It says find S sub 10 of the sequence 3, 6, 9, 12, etc. So this 10 is telling you to add the first 10 terms. Now, that's not very many. So in theory, we could just write this out as a long addition problem and then add them up. And that would work. That is absolutely what we're going to do. So we would be adding 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21 plus 24 plus 27 plus 30. That would be 165. So S sub 10, the sum of the first 10 terms, would be 165. Now that's not always going to be that easy. We're sometimes going to have to add up dozens or hundreds of terms. You don't want to have to write all of those out as one big addition problem and then type them in your calculator. So we need some equations that will work every single time. We're going to have two equations for arithmetic series. The first equation, and again, these equations are going to be slightly different than the versions used in a pre-calculus class or even most Algebra 2 classes, because again, I've taught arithmetic sequences point-slope form, which means that I'm using y instead of a, and I'm using m instead of d. However, this would still work. You would just need to substitute in those variables. When we know the first term and the last term that we are adding, so the first term and the last term, or nth term, we're going to use what is called the general equation for an arithmetic sequence, and that would be that S sub n, the partial sum, is equal to n, the number of terms being added, times the average of the first and the last terms. So y1 plus yn divided by 2. We're going to use that most of the time. In fact, I think we use it on every example we looked at in the notes, and I don't think we need the other format even on our homework. There is, however, an alternate form for when we know the first term and the common difference and nothing else. Again, I should have used a y there. So when we know the first term and the common difference, we're going to use the alternate version of this. Common difference being what gets added every time in the related sequence. That version is going to be that the partial sum is the number of terms divided by 2 times twice the lead term, twice the first term, so 2 times y1, plus the common difference times 1 less than the term number. We're not going to use that version very often, but again, all of these different things are variables we should recognize. Okay, our S sub n, that's our partial sum. In this case, this is the arithmetic series. Same thing down here. S sub n is the partial sum. In this case, it is the arithmetic series. N, and it's the same N for the subscripts. Okay, this N here is the term number, or number of terms being added. It's also that N right there. They're all the same. Okay. Then we've got the first term, y1, and the nth or last term being added, yn. Down here, it's the same. N is the term number, or the number of terms being added. So all three of those n's mean the same thing. That's the term number. You've got y sub 1, which is your first term in your sequence, the first term that you're adding, and you have your common difference, the amount that the sequence is changing between each term. So let's practice. We're going to do a number of examples. This probably will end up being the longest video in this series. So here we have, whenever the computer decides to change it, we're being asked to find the sum of the finite arithmetic series, 12 plus 19 plus 26 plus blah, 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 until we get to 180. So here we have the first term, y1, is 12, and the last term, y sub n, is 180. We can also see from looking at this that the common difference is that we are increasing by 7. Now there is one very important thing missing that we do not know, and that is we do not know what n is. So we have basically a two-step process here because we can't find the arithmetic series without knowing how many terms we're adding. So our first step is to find the term number n of y sub n. Now we're going to do that by altering our point-slope equation, and we're going to insert n for x, which means that the y at the beginning would be y sub n. So that would be 180 minus 12. Again, those are in red because I marked them in red earlier in the page. Equals, we know that the common difference is 7. We do not know n, but we know that the first term is 12, which means x sub 1 is 1. Everything in that equation is known with the exception of n. So we solve for n. 180 minus 12 is 168. We distribute the 7 to get 7n minus 7. That makes this into a two-step equation that every Algebra 2 student should know how to solve. So again, what we did there, we added these like terms and we distributed the 7. So now we're going to add 7 to each side of the equation, which will give us that 175 equals 7n. That turns that into a one-step equation where we divide by 7. 175 divided by 7 tells us that n equals 25. So that takes us to step 2. Step 2, we are going to find s sub n, and we are going to use the general formula because we know the first term and the last term. So s sub n is n times y1 plus yn divided by 2. Plug in what we know. We know that we are finding S25 because n is 25. Y1 is 12. Yn is 180. So plug in what we know. 2 is going to bother me. Let me fix that real quick. And then we're going to be simplifying this down to a single number. So we start, order of operations says we do 12 plus 180. So we have 25 times 192 divided by 2. Then we would do 192 divided by 2, which would be 96. And then we do 96 times 25. So 96 times 25 gives us a partial sum, S25, of 2,400. Let's do another one. So here's the next one, same idea. We know the first term, y1 is 2, which means x1 is 1. We know the last term, y sub n is 100. And we know the common difference, it's increasing by 2. So m is 2. We do not know n. So our first step, step 1, is we need to find n. And just like the last problem, if we plug in n for x, so we're going to put an n in here instead of x in our point slope form, then y becomes y sub n, which we know. So we're going to plug in everything that we know. We know that y1 is 2 and x1 is 1. We know that m is 2. And we know that x sub n is 100. From there, we're going to simply solve that equation. So we're going to add like terms on the left side. 100 minus 2 is 98. I actually would prefer that was in black. So 98 equals, and we're going to distribute n, giving us 2n minus 2. That's a two-step equation. So we're going to add 2 to each side, which gives us 100 equals 2n. And then divide by 2 to give us that n equals 50. Now that's not the answer to the question. We need s sub 50. So now we're going to go find s sub n. And again, we are going to be using the general form of the equation. So s sub n is n times y1 plus yn divided by 2. That is s sub 50 equals 50 times 2 plus 100 divided by 2. Again, we're just going to simplify that down to a single number. So 100 plus 2 is 102, which means we're looking at s sub 50, if my pen will work, is 50 times 51. So S50 is 2,550. Let's do one more. This is a step up in difficulty, but not much of a step. So instead of giving us the actual series written out as a sum, they've given us information about the series. They've told us that we want to find s sub n if n equals 16, which means we are finding s sub 16. To do that, we need to know the first term, the 16th term, and the n value. Now, if you look at that, we know two of those three things. We do not know the first term. So our first step, step 1, instead of finding n, we have to find the first term. We are, however, still going to use the exact same equation. We're going to plug in n for x. So we're using the same equation we used in the last two. We have y sub n, which in this case, if n is 16, x1 is 1, m is 8. If we plug in 16 for n, then y sub n would be 240. So again, this is an equation that we know everything in the equation except for y1. So we're going to solve that equation for y1. That would involve doing 16 minus 1, which is 15. Then we'll do 15 times 8, which is 120. So 240 minus y1 equals 120. That is a two-step equation, and if we're not careful, we're going to lose one of those steps. Our first step is to subtract 240 from each side, but we need to be extremely careful not to lose this negative. That gives us that negative y1 is negative 120, and then to get rid of the negative, we would divide each side by negative 1, which tells us that the first term in the sequence, the first number that we are adding, is 120. Then we advance to step 2, which is to find s sub 16, or s sub n, and we have what we need to again use the general equation. S sub n is n times y1 plus yn divided by 2. So that's s sub 16 equals 16 times the first term, which we just found is 120, plus the 16th term, which is 240, divided by 2. Again, from there, it's all calculator work. We're just plugging and chugging. So that'd be 360 divided by 2, or 16 times 180. Feed the calculator. That is 2,880. Our next video will explore sigma notation as it applies to arithmetic sequences.